The second homework problem says that the motion of a particle is given by the equation x is equal to 2t cubed minus 15t squared plus 24t plus 4, and we're asked to determine when the velocity v is equal to 0 and what the position in total distance is when the acceleration a is equal to 0. So we can start off by figuring out when our velocity is equal to 0, and our velocity is the derivative of x with respect to t. And we have the equation for x. So the derivative of 2t cubed minus 15t squared plus 24t plus 4 with respect to t is equal to 6t squared minus 30t plus 24. And we want to figure out when this is equal to 0, so we can set the equation that we just got, 6t squared minus 30t plus 24 equal to 0. When we solve the equation, when we solve it for t, first we can simplify it a little bit. We can take a 6 out of the equation, so this becomes a 5, this becomes a 4, and we get t squared minus 5t plus 4, and this is t minus 4 times t minus 1 and is equal to 0. So t is equal to 4 and t is equal to 1. What this means is at t is equal to 4 seconds and t is equal to 1 second, our velocity is 0. So there's 2 points that our velocity is equal to 0. Now this is part A. Now our second part of the question asks to determine the position and total distance when acceleration is equal to 0. So acceleration is dv dt, and this is equal to, this is our equation for v, so the derivative of 6t squared minus 30t plus 24, and the derivative with respect to t. When we take this derivative and we do it out, we get 12t minus 30. And again, we want to figure out when this is equal to 0. So when we figure this equation out and we solve for t, we get t is equal to 30 over 12. What's that? That's 2.5 seconds. So at 2.5 seconds, our acceleration is equal to 0. And to find what the position is when the acceleration is equal to 0, we put this time we found, the t, into our equation for position. So at t is equal to 2.5 seconds, x is equal to 2 times 2.5 cubed minus 15 times 2.5 squared plus 24 times 2.5 plus 4. And if we do this out, it will be, we get 1.5, and our units are meters. So this is the first part, the position of part B. And the total distance, we have to break this up, and we have to look from initial time of 0, of t to when the acceleration is equal to 0, which is 2.5. So we have to look at what the particle is at all our instances between 0 and 2.5. And how we can break this up is we look at where our velocity, a good point to check is when our velocity is 0. We know that at time is equal to 2.5, our position is 1.5 meters. So t is equal to 1.5. X is t is equal to 2.5. X is 1.5. And we want to check 0 because that's when we begin. So at t is equal to 0, x is equal to 2 times 0 cubed minus 15 times 0 squared plus 24 times 0 plus 4. And all these terms are multiplied by 0, so they just go away. And we're left with x is equal to 4 meters. So at time equals 0, here's 1.5 meters. Our x is equal to 4. And we want to check again where our velocity changes. So we want to check at t is equal to 1. And when we plug this in for x, we get x is equal to 2 times 1 cubed minus 15 1 squared plus 24 times 1 plus 4. And when we do out this calculation, we get 15 meters. So this isn't really to scale, but so at time equals equal to 1, we're actually over here, and we're at x is equal to 15 meters. Now, to figure out the total distance traveled, we have to sort of trace where our particle goes. So from t0 to t1, we know our particle is going in this direction and has moved this amount of distance. And then from t1 to t2.5, we know our particle is going in the other direction and has moved this amount of distance. And we need to add up this total distance. So if we call this right here our delta x1, our change in x1, and this from t1 to t2.5, our delta x2, we know our total distance is going to be equal to delta x1 plus delta x2. And now we look at delta x1, we know it is our final minus our initial, and because it's the total distance traveled, it's the absolute value of these two numbers. So our final is 15, our initial is 4. 15 minus 4, and this is 11 meters. Our delta x2 is our final position, 1.5, minus our initial position, which was 15. And this is where the absolute value signs come in, because the 1.5 minus 15 is minus 13.5 meters. And because it's the absolute value, this is really equal to 13.5 meters, because we're looking for the total distance traveled. So now we know the total distance is delta x1, 11 meters, plus delta x2, 13.5 meters. And our final answer is the total distance traveled is 24.5 meters.